All right. All right, hey guys. So I am going to teach you guys some, like I said before, just some basics of character rigging. I'll go through generally the whole workflow. I won't use this character. I'm just showing them as an example because I can go in. I'll talk about the basics of either FK or IKs. If anyone's interested, I can always go into more complex stuff like twisting, or other things like that. I'm gonna be using Maya as an example, so I'm gonna be going over all the different constraints on here. If you're using like Blender or other programs, then it hopefully will translate as much as possible. But I can try and answer your guys' questions as much as I can. So this is like my character that I'm working on right now for thesis, and it's like a um, I did like a photogrammetry, I guess a 3D recreation of like my sister because I wanted to make a hyper realistic character and I used my sister as a subject. So um, the only thing's really working on her eyes because the face is just too much of a hassle to really do and I don't have time. So unfortunately, I can't do that. But I can get started. So let's open up a new scene first. I just thought this could be something to look at while I'm talking, so it's just not boring. But okay, so I'll make a sphere, cylinder. I know my shapes. Let me scale this up really quickly. I am dumb. This, like that, and then let me give him some subdivisions. Okay, so I guess the first place to start is we're just going to start making our bones. So, I mean, in the difference between, I guess, I'll start with like the where the root bone would be. I guess typically, on a human or even a quadruped, usually the bones have to all stem from like a certain point on the body. Typically, they're in the pelvis area, so wherever it is on a quadruped or bipedal, person, like it would usually be in the hips. But in this example, I'm just going to be starting it on one end of the tube. So whatever program you're using, I would just, select on the bone tool. And if anyone's using Maya, there's like a weird thing with Maya. It's like you have to make sure that you're clicking on the plane. Otherwise, it doesn't, create a bone anywhere. But just make life easier. I'm just going to make it on the top camera. I'm going to click or press and hold X so I can snap it on the grid. I'm not worrying. I'm just eyeballing spacing with the snap tool. And again, if you guys are using other programs, you can use like little techniques like this. Hopefully they will transfer. So I'm going to go up to my show tab, shading, and click X-ray joints. I know you can do this in Blender too. It just makes life so much easier because you can see your joints through your object. You don't have to go in wireframe mode. And so I guess let me explain what an FK is first, and IK. So let me just hide the cylinder. So FK stands for forward kinematics. Forward kinematics will mean like, I guess like a dumbed down version, because that's the only way I can explain it, would mean is that whatever's happening at the end, this is considered a bone chain. And in the hierarchy, you have joint 1, 2, 3, 4, 5, and so on. Forward kinematics means whatever's happening on this joint, it's going to affect the rest of the joints in the chain. So when I click on the first one and I rotate it, it's going to move all of them. And so when you have characters, like for example with their arms, you can have, if you want them to raise their hand or wave, it makes it easy because you can just lift up this this joint and then you would lower this one and all that, and it would just make it easier that way. But let's say you have like a complex, or you want your character to do something more complex, like say for a person you want them to do push-ups and you want the hand to stick to the ground the whole time. Obviously, doing an FK method would be very impractical, and the hand would always move. Like, it would almost be impossible to get it perfectly still. So that's why you'd have IKs, or inverse kinematics. So you can imagine forward kinematics, the beginning of the chain affects the rest. Inverse kinematics is literally the other way around. So I'm going to go up here. I'm in my rigging tab. I'm going to click on this. I'm going to double click it. And we have these two options here. I again, forgive me, I don't know if Blender has these two options, but you know, forward plane solver is what the typical IK is. That's in either Cinema or any other program. So I'm going to click on the start of my chain and click the last joint in my chain. And all this will do is that I'll be able to grab this handle here, and when I move it, it should bend. Now the reason why this is not bending is because when you rig your characters, you want there to be a very slight bend in the joints. Otherwise, the IK is not going to have any idea like how to bend. You know, this little arrow here at least is referred to as the pole, or the pole vector. And in this case, it's pointing down, but because still the joints are not bent, it's hard for it to know like what the heck to do with it. So I'll do this first, and then I'm gonna go into another step that's actually pretty crucial, because I just want to explain the basics of IKs first. I have no idea if bending one joint is gonna do it. I'd assume it would, so I'm just gonna do this. Nope, that didn't do anything. Hold on, let me check my settings. Let's do this again. I'm just gonna bend it like that, and I'm just gonna freeze it real quick and go with that. Now this is probably what's also affecting the IK, so let's just test this out first, and if this doesn't work, then I will have to do another step that will probably solve this problem. Okay, well, that actually worked. Awesome. So you see, like, I have an IK handle here, and I can do whatever. Well, unless I go back here and grab the top of the chain, this joint is now locked in space. This joint is now controlling what's happening to all the other joints. So what I was going to go into real quick is, before you put on IKs on any like bone chain, you have to do something called orienting your joints. And so what that is when you click on the joints, you can see what axis the joints are, you know, what is pointing down the chain. And you can actually see on this joint versus the last joint, their different axes are pointing in this direction. So we want all of them to not only face technically the right direction in relation to world space, meaning all these joints technically, the axis pointing down the chain should be on the z-axis. We just need to make sure they're all facing the same. In Maya, the way you would go about doing this is that you have to go to the Orient Joint tool under Skeleton, and you want to hover over the box, you know, the settings, and then you have to choose what axis, the primary axis that's going to be going down the chain, and I want that to be Z. Sometimes it's a little finicky to know what these two we set them to. I typically just make them the same. Otherwise, if I have this as X and say I have this one as Y, we don't want it to be also the primary axis. Things just get wonky. We want to always make sure Orient Children is selected, unless you're doing something very specific. If you're adjusting a certain joint and you don't want the rest of the joints in the chain, you know, the children to this bone, to change, you should just, I guess, check it on. But we're going to try, I'm going to see, so I know Z should be going that way. I'm going to say Y is, I'm going to guess Y. And it doesn't work because my joints are not frozen. because I deleted the IK. So make sure you freeze your joints. I don't remember, honestly, if Blender you ever have to do that. I never froze anything when I used Blender, so. Okay, yeah, I got it right on the first try. Dope. And one thing to keep in mind when it comes to orienting joints, and this applies to whatever program you're using, let's say you're making a character and they're standing up. So you would start, the bone would start at their hips and go up their spine, right? So now the primary axis for the rest of the skeleton is the y-axis, which means even as the chain is going up the spine, down the arms, down the fingers, you want y to always be pointing in the direction of the actual skeleton. If you're making an animal where they're on all fours, let's say we're facing towards the X and you make your joint, you want X to now be your primary axis, and now X is going to be flowing up the spine and down the arms and so on and so forth, because it just makes, when you put inverse, or when you put IKs on everything, it just makes the skeleton behave properly. And you always want to base it off of whatever axis you have it in on the world axis. So now I oriented all these joints. Sometimes you'll have to like go to the last joint and orient the joint, but have it set to orient joint to world. This will basically take whatever orientation is from the previous joint and set it to that. You see it did snap a little bit when I did that. So in my case, like when I was rigging the characters to my female character, like when I was rigging the fingers to my female character, I had to go to the tips of the fingers and reorient that. But all right, so now we have the joints oriented properly. Now this would be the step where we would properly like IK, or put an IK on the rig, and then now we can move it around and all that stuff. I guess now that we're here, the next step really would be the pole vectors, and so I can actually start going. I'll go really quick into these various constraints, and these constraints you're not really going to use until you make your control curves. So when if you remember all the rings and loops that I had on my rig, those were controlling the joints based on these constraints, and I'll go through them in a second. After that, I can let's see, I guess I'll go into the constraints, and then I can go into the binding the skin and weight painting. So let me straighten this out really quick, just so we have the cylinder back in line with it. Let's see. All right, let's make a curve. I'm just going to scale it up as if I was going to make it a control curve, and I'm just going to snap it all the way down here. So the constraints, at least in Maya, are very simple. You have we'll start with here, point constraint, meaning whatever object you constrain it to, it's only going to control the translation values on that joint or IK. You typically do this on IKs for location, at least. Orient constraint has to do with rotation. So whatever you constrain it to will only like for example, if I were to constrain my curve to my joint, if I were to orient it to the joint, it would only control the rotation values of this joint. Scale constraint, it's only for controlling scale. Aim constraint's a little bit complex. I'll go into that in a second. And pole vector specifically for IKs, and I'll talk about that right now. And then lastly, parent constraint is literally just point constraint and orient constraint together, and you can double click and change it to whatever values you want, or whatever axes you want it to affect. So pole vectors, as we saw, let me know if I'm going way too fast. I might be going a little bit fast, but I figure these are like pretty basic concepts. But I am recording this, and I'm not going to screw up my recording like I did for XGen. So like, this one will hopefully go on YouTube like very soon. So we, as I mentioned before, that this is the pole the pole vector for the IK. That's what's determining like how it's bending. So because it's pointing up, the chain's bending upwards like that. So this would be very handy if we had something like legs or arms, where we want the elbow to point in a certain direction. Obviously, we wouldn't have these many joints. We'd only have 1, 2, 3 joints. So technically 2 bones. And we want to put an object to pole vector constraint it to the IK, so then we can guide it where we want the chain to move. So in Maya, you can use 2 objects. You can use a I'm pretty sure you can use a locator too, but I don't know. I probably wouldn't do that. You can use a curve to control it. This is a curve, or you can use a normal geometry, and you would just go into the display settings to change how it looks and make it look more like a curve. If I were to do something like this, I turn off shading, and all of a sudden it looks like a wireframe. Again, apologize for rushing, but that portion, I'm just showing that you can make a geometry into like a wireframe for it to be a control curve. So actually, let's just use it for this in this case. So I put it directly above the chain because, again, I want it to start in whatever default position this pole vector or the IK is facing. I just want the pole vector, or what I'm going to turn into a pole vector, to be already facing. And you want to make sure that you always, all your curves, when you get to this stage in rigging, this is something you would technically do after you've built your skeleton. You're going to make the curves, the control curves, to control the skeleton. You want to make sure you freeze all of your curves, all your control curves. So that way you'd be able to select all of them, and you have your character in a whole pose, and you can easily reset it by just selecting all the curves, changing your translate and rotation values, and scale if you have any scales to 0. And your character will go back into like a pose or T pose. So real quickly, this will be the pole vector. I'm just going to click on this object, then the IK, then I'm going to click pole vector. And so now, if I move the IK, and it's bent like this, I can now move this ball, and it will now move, always be facing the IK. Because again, the IK, you can't really go off this arrow now. It's like the default position. But technically, the chain is now always facing towards the what would be the pole vector. And obviously, if you flip it, it's going to try and flip upside down. So this is how you would like control your, again, your elbows, your knees, all that stuff. And to make life easier, I'm going to just straight up parent constraint this curve to the IK. So you can either parent constraint it, or you can just drag in the hierarchy the IK straight into the curve. And that alone will already like move everything for you. Rotation doesn't really matter because, again, it's the IK. So now technically I could animate this. I could animate the curves, and I could make my joint move. I guess that leaves left the aim constraint. And then we'll go into weight painting and all of that sort of stuff. Aim constraint is pretty complex. I'll talk about it actually. Let's talk about it. So let's reset this. Basically what an aim constraint is doing is it's exactly what it says. You're going to take a joint and have it face towards an object all the time based on a certain axis, whatever it's facing. It's essentially a pole vector, except you can do it with almost any object. It doesn't have to be a joint. It can be other geometry too. The only method I have used, you have these different world up type settings, and some of these are pretty straightforward. Like you would have a similar to the orient constraint, how we had a primary axis and a secondary axis. These are referred to as like a forward axis, or in this case an aim vector, and then you have an up axis, or in this case an up vector. It's always going to take two of the axes of the object, and one is always going to be facing towards the object you're aiming it at, and it always needs another one to know where it's facing in space. So I haven't used vector. I haven't needed to use scene up. The one I have used for my character rig was object up, because you can type in the name of the specific object you want it to face. In this case, technically the secondary axis or the up vector, so it can keep its proper orientation. So I guess I will show that with, I'll show that with this joint, because that will make life easier. It's the last joint. So we need to make an object for this to point towards, and then we need to make another object in either directly above it or to its left, so it's constantly facing that object too, so it stays upright. Again, for the aim axis, we can use either a curve or geometry, other kind of polygon. It doesn't matter. The one thing that you can't use, though, that I've learned the hard way, is you cannot make your aim object a locator, because a locator, at least it's in Maya. Yeah, locators exist in Blender, but I never used them. I know in Maya they have some special properties that kind of screw up with the aim constraint, and you can only use it as an up vector. You can't use it as an aim vector. So what I found to work is that I would make a curve. I'm just going to face it because it just looks better. I'm going to not align it perfectly with the object, because then again it's going to confuse it. You have to put it at least a little bit in front or really in front, doesn't matter. I'm going to freeze this. I'm going to use a locator. For the aim vector, you probably want to use a locator, or the up vector, sorry, you want to use a locator purely because I found this very interesting. So actually I'll just show you rather than tell you. So if I use a curve and I'm going to put it on the X, what I'm going to do is I'm going to take the name, so it's NURB Circle 3. I'm just going to click it and copy it. Now the way aim constraint works is, let's look at the joint first actually. So we know we want the positive Z is going to face towards this curve. Then the positive X is going to point towards this curve. So we want to select the aim object first. Then we're going to select whatever we want an object to aim to this object. So in this case, it's the joint. I always forget what order it is. I basically just summarize it in my head as, I want the joint to aim at this, so I'm going to select this first, and then I'm going to select the joint. We don't have to select this, because we're going to actually put it in here. So that is now going to be the up vector, but now we need to change these values that are, X, Y, Z, to make sure they're facing the right direction. So third row or third column is X, so I'm going to make that 1 and get rid of the 1 in the X axis. Then for the up vector, I'm going to make this 1, because this would be X, and I'm going to get rid of it in the Y. And I'm just going to hit OK. And so now you saw like it did a little bit of a snap, but it's fine. So now, whenever I move this object, which is now the aim object, it's always facing it. But as you can see, even as I move it, well, actually, I take that back. Actually, it kind of does work. but it will make more sense on this side. So this is now the aim vector. So now I can move this above, below it. I can move it side to side, and it doesn't actually change. And that's because it always is aiming towards this on the Z, but the X on this joint is always facing in whatever direction this object is. So the reason why, it's hard to explain why you want to do this, but as you get, if you guys ever get really into rigging and you start doing like twisting joints and all this stuff, that's when you would use aim constraints. It's when you would use twisting. That's really like the, at least that I could find why I would use aim constraints for either twisting joints, or I'd use them for the eyes. How I want the eye joints to constantly face a certain curve. The only last thing for constraints before I get into weight painting is under all of these different constraints, if I double click it, you have like a main offset checkbox. All that does is that when you have it turned off, oh, actually I didn't get into the aim constraint thing really quickly. Let me backtrack onto that. I apologize. I guess it's not all that important actually for this little tutorial. So let me do just a simple maintain offset example. Let's use a cube. Boop, boop. Freeze both of them. Alright, so let's say I want to parent constrain this, or this rather, to that. Or is it the other way around? My brain can never remember this. Okay, yeah. We're going to parent constrain this to the cube. So when you have maintain offset turned off, say let's actually rotate this and let's parent it to that so you can see it better. So if I parent this, or, oh Jesus, this to that, I'm going to select the sphere first, then the cube, and I have maintain offset turned off. It's going to snap it and lock the rotation right onto the object that you have it parenting to. And the same applies with orient constraint and location constraint. Now that I deleted the constraint, it's now stuck in, back in space like that, which I'm just going to reset. But if I have maintain offset turned on, it's going to constrain it, but it's not going to actually change it. So this is now like the starting point of the object. And now if I were to spin it or move it or whatever, it would move it like that. It's like the same thing as parenting in the hierarchy versus, except it's not actually under the other object in the hierarchy. So that is the maintain offset. I guess, do you guys have any questions right now, or anything that I didn't cover that you're curious about in this part before we go into like weight painting and skinning and all that stuff? I apologize again for going like a bit fast, if anyone's trying to follow along at least. All right, COVID class. Silence means no questions. So I'm going to continue then. I think I still have this as a pole vector. So let's bring back that cylinder. All right. So I will go into it as, yeah, let's just explain it real quick. So I guess for skinning objects in Maya, you're going to select the joints first, and then you're going to select the mesh. So if you have like crazy joints that are all not parented together for whatever reason, you just want to make sure you select all the joints that you want. Actually, no. Okay. Let me go into I think that's the skin button, is it? Nope. There is no skin button here. I'm going to go into the radial menu, skin, bind skin, which actually is that button. Great. In the settings. So actually this is what I'm referring to. So most of the time you only need to select the hips, and then if you have bind to joint hierarchy, it's going to, you know, automatically select all the joints in your chain. But if for some reason you don't want certain joints to be selected, that's when you would switch it to selected joints, which is what I was talking about before. But it still is the same, where you want to select the joint hierarchy first, or whatever joints, and then you select the mesh after. So Maya has a few different binding methods. I never use closest in hierarchy. The ones you typically are going to use are like either closest distance or heat map or geodesic voxel. The problem, heat map probably in my opinion gives the best results, and I know Blender has like a heat map option, and heat map is like real nice. The only problem is that if you have a mesh that has, if your character for example has several meshes that are not actually all combined into one like mesh where the topology is all connected, all this stuff, heat map doesn't work. So you have to use geodesic voxel for that. And these two methods are typically have a lot better binding results compared to closest distance. It really doesn't matter what option you choose. It really just it gives you like a better starting point, honestly. So for this case, I'm just going to do closest distance. I never really use anything other than like classic linear, weight blended. They don't really do anything. I just do weight blended just because. Dual quaternion is nice. I'll show you what it looks like. But the problem is that if you want to make this into, if you want to move this character into a game engine, for example, not a lot of game engines, or at least Unity and Unreal, don't support dual quaternion. So yeah, you just want to use either classic linear or weight blended. For normalizing weights, this is actually pretty important. I'll show what this does. I'll have it set to interactive first, because by default it's typically set to interactive, and weight's always based off distance. I haven't found a need for neighbors yet. All this stuff is something you would just have to play with as you do it, but we'll just start with these settings. So now we'll see, like, as I move the joint, it's now moving my cylinder. For the most part, it's doing like a good job. There's like a little weirdness here, but other than that, it's like fine. So I guess dual quaternion might not be the best. Maybe I can show it. Let's see if I can break this rig. First, I would have to turn off the IK. So when I turn the IK blend to 0, this now turns into an FK rig. And I can do something like twisting, where it does something like that. And if I twist this, then it'll do that. And let's see if I change the skin method, will it change it? Yeah. So dual quaternion will like help with twisting joints, for example, because it will help keep the thickness of the geometry. But it's like as soon as you do something where it's bending at like a 90-degree angle, sometimes it will work really well. Sometimes it'll give you like a huge extra, your geometry will just morph in a very weird way. So dual quaternion is nice, but it has its flaws. And again, game engines don't support it. So that's all I want to show for the dual quaternion. So for weight painting. Oh, geez. Let's just turn back on this IK and forget everything ever happened. And now my FK is completely broken. Or my IK. I don't know what happened here. Wonderful. Let's just undo all this. Alright, am I safe now? I am. Alright. So let's go into weight painting. This portion, this annoying stage. It's so freaking annoying. Okay, so what I was talking about before with normalized weights and how you have like an interactive or a post. What interactive does, and I don't know if Blender has this, and I keep bringing up Blender because I know Ray and Spencer use it. What interactive is going to do, that if I add weights, let's say I have, you know, joint 5 selected, this mesh or this joint, and I add weights to a different section of the mesh, with normalized weight set to interactive, it's going to add weights onto this portion of the mesh, but it's now going to remove weights from whatever this part of the mesh was already binded to. So if I go now to like joint 2, there's now a gap in between because it removed it from the other joint. Now, early on, this could be very helpful, and it can be very handy when you're trying to quickly block out the general geometry first before you start blending everything in. But I typically find it very annoying. So I just don't like using interactive at all. I used post for my character. What post is going to do, if you set your weights to post, it's going to give you this little warning. I'm going to click yes. It's now you can now add weights to certain parts of the mesh, and it's going to keep it there on other joints too. So let's say I paint this now white, and I go over here and paint it white. White meaning, you know, full influence onto specifically joint 2. If I go down the chain and click joint 6 and joint 5, the weights are not altered here at all. It didn't remove the weights on here. So basically what that means now is that now this mesh is now being pulled by 3 joints at the same time. So you would have to remember to go to these specific joints and remove it, but it really makes fine-tuning weights very easy. It saves you a lot of headaches. I'd say for complex characters, like for people or animals or whatever, whatever. Well, robots are a little different. I start out, let's say I flood everything and I start from scratch with 0. I mean, this is probably not a good idea because it's just going to bring all the points to the center because now there's no weights on anything. So I just flooded all the geometry to this mesh. What I usually do is I will go with the hardest brush that's available, the most solid brush I got, and I'll just go with just straight up paint it in very, very crude like chunks. Because the idea is that you would like, okay, I know I want weights to be on these joints. I don't know how much, I don't know how it's going to blend together, but I just know that I want this joint to affect this part of the geometry. So I'm just going down the chain, just very quickly painting it. And this also helps, this is also easy for me because I have it as a cylinder and it's already like lining up with the joints. So if you have complex rigs with more complex topology, then don't worry unless you were really good with your topology and like things are already, the shape of certain joints is like matching really well, then don't worry about like getting the flow of the topology, because after that you can just smooth everything out and then in theory it should just work. In Maya you have like a smooth feature that you can just flood it and it will just automatically smooth it evenly for you. And I'm just going to go to every single joint and just hit flood a few times to blend it in. This is the first joint in the chain, so I would actually have to remove all these weights. So I'm going to go back to replace. I'm going to hold control and it's going to give me the opposite of my value. I have value set to 1, so holding control gives me 0. I'm just going to paint back up to this joint that I started with. Otherwise, it's going that whole the mesh will be partially influenced by the first joint in the chain. And then I'll go back and flood this real quick. And this probably won't look all that great, or it might work perfectly fine. Yep. So now the weights are all there. Now if I were to have this flooded, for example, in just the first joint in the chain, you're going to see that the mesh is not really following it properly, because again, this joint is now affecting almost 100% or throughout the whole thing. So I guess in terms of like a simple workflow, again, just brush it on very roughly, very crudely, then try and smooth it out. And then that should be like a good like jumping off point. Then you can do your more fine stuff. Just make sure you have your weights, normalized weights either at post when you do more refining. The other thing I know Rhea was asking, and I'll show this, is, you know, the character that I showed before, all her clothes, she has several layers of clothing. She has 3, and the weights all worked fine. The way I did that was Maya has a special like skinning tools that help me duplicate the weights from one object to another, regardless of topology. Obviously, like having similar topology is like very helpful, but you know, even in my case, it actually didn't matter. So I had this option. Well, you have mirror skin weights. Obviously, you know, you would paint the skin weights on one side, and then you use this tool to make sure you flip it to the other side. So you have even weights on both sides if your character is symmetrical. If they're not symmetrical, it could potentially work, unless, you know, their geometry or their topology is so different. But the big thing that helped me was the copy skin weights. So I have, let's say I have this, and let's say I want to make, let's make a tube, a square tube, just because. So I'm gonna do that. Gonna give it edge loops just like the cylinder. Don't matter. I'm gonna bind it just like I did with the cylinder. I'm not gonna do anything special, just do the same thing. But now this is not gonna be the best example, because again, it's like, it's just one line of joints. It's nothing really complex, but this should still hopefully get the point across. So let's say I screw up these weights just to prove a point. I'm gonna flood it on here. So now it should do what the cylinder did before. Oh boy, okay. I have a chair or something. So let's say I want these weights to also be applied on this one exactly. You don't want to copy the weights when it's like this, otherwise it's not going to work. You do want the geometry to be in its like default state as much as possible. Otherwise it won't work properly. So it's as simple as just clicking on the object you want to take the weights from, then copying it onto this cube tube thing. My brain can't think of words. I'm just going to go here and click copy skin weights. And now when you look at the weights, they're back. They're looking proper. And now when I move the joint, they'll move very similarly, if not perfectly. But again, it is based on the topology. I think my square prism tube thing has more edge loops than the cylinder, so, but it's following it pretty closely. So I was looking into it earlier a little bit for Rhea with the whole see if Blender has an equivalent to this. I don't know, to be honest, because painting it by hand would be a nightmare to match up the topology. Let's see. I guess that's it for the basic stuff. Is there anything that I didn't cover in terms of basics that you guys are wondering about? Did I answer your guys' questions, like Ray and Spencer, with like weight painting at all, or are you still confused about something?
I'm good.
Okay. Were you just wondering like how to go about it, or?
I mean, I've done it. I just wanted to see how uh others do it, because sometimes my joints come out looking real funky.
Yeah, it's one of those things where it's like there's not really a special workflow for it. It's just you do have to keep just messing with it until it works, how you want it to. So, I guess if anyone doesn't have any questions, then I could stop it there, unless anyone is curious about like more advanced stuff. I guess more specifically like twisting and all that. Well, for something like forearms or other things like that. But don't got to. Let me check if there's let me check the
Now
chat.
do it in Cinema 4D.
Do it in Cinema, okay.
Yes, do it in
Yeah.
Well,
please.
y'all would have to do that, right? Either.
I don't know how to do any
Yeah.
rigging in Cinema.
All right, well, Anisha would have to
Dude,
teach
you
that
wanna see
then.
my rig?
Anisha
Dude,
would
I
have to
was talking
teach.
to Erica. The fucking rig y'all built, that shit's incredible.
Yeah.
Yeah, it took me
What
forever
one
to
day
get
yeah,
there.
after the semester's over and I'm not dying, then yes.
Okay, okay. Yeah, I'm trying to mess with the tail right now, and I just messed it up. Here, I'll show you my wonky IK.
All right, then I guess we are good then. Because I
That looks like a churro.
could go for a churro right now. Shoot. Um. Do. I'm opening up back Ash's rig, or at least my thesis character. Do. 30 seconds to load. Yay. Oh, I don't think I saved the changes on the hair. So much for that.
I might have to reset this.
You have limits on those?
Nope. I don't have limits on anything except the twisting joints I had, like on her legs and stuff. But apparently, Nick said this too. Like,
You shouldn't have limits.
yeah, they don't like animators don't like
Yeah.
limits. Apparently,
They like to well, you saw the like the breakdown for Into the Spider-Verse. They literally like they duplicated the geometry. They put it somewhere else in space. They literally would like delete half of the polygons to create like a motion blur kind of effect to get the animation movement they wanted.
Yeah.
So I understand why.
Yeah. Right. Actually, you know what I'm gonna open up? I'm gonna open up Aang's rig. I still have his rig. Like
Limits
the free
might only
Aang
be
rig.
I don't know, maybe Max could correct me on this. I don't know. Maybe limits are just good for like agent simulations and shit like that. More.
Actually, let me show what I'm using it for in this rig actually. Because I have locators like all over the Aang, get out of here. Let me stop the recording. I actually didn't do that either.